everybody. Now it's time for a movie on confidence intervals. We've already seen different aspects of hypothesis testing. Now let's take a look at the confidence intervals. And we know that these are called 1 minus alpha times 100% confidence interval for mu. That being said, I can say with 100% certainty that mu falls between minus infinity and infinity, but that doesn't give me a lot of information. So what I'm going to do is give up a level of risk, which is a probability that I'm going to call alpha, and I'm going to try to narrow down my interval based on that. So there's your formula. You have x bar plus or minus z with the subscript alpha over 2 times sigma over the square root of n. So in all of your problems, you're going to be given alpha, my fault, you're going to be given x bar, sigma, and n. You must find the z value. And the z in that formula is the horizontal z, not the probability. We're going to use the probability to find the horizontal z. Suppose a large airline wants to estimate its number of unoccupied seats per year. They randomly select records from 225 flights and find a sample mean of 11.6 with a standard deviation of 4.1. Find a 90% confidence interval for mu. So let's scroll down a little bit. So in our story, we know that x bar is 11.6, sigma is 4.1, and n is 225. So we have to find our z value, and we start out with 1 minus alpha equal to 0.90. That 0.90 is essentially the 90% in decimal format. So we take 1 minus alpha over 2, which is equal to 0.90 over 2, which is 0.4500, which is a probability. So we're going to use that to find our z. We look in the middle of the z table where the probabilities live, and the closest value we have is 44.95. Then the z that's attached to that, you pick up the 1.6 from the row and the 0.04 from the column and get 1.64. So now we're going to put this all together. We're going to have 11.6 plus or minus 1.64 times 4.1 over the square root of 225. That's going to give us 11.6 plus or minus 1.64 times 0.27333. Then when we multiply that together on the right hand side, we have 0.45. So when we do our subtraction, we have 11.6 minus 0.45, and that gives us 11.15, less than mu, less than the 12.05, which is what we get by adding 11.6 and the 0.45. Now the interpretation for this is that we are 90% sure that mu falls between 11.15 and 12.05. So when you ask for the interpretation, that's all it is. Thanks.